So let's move on to another orbiter, the Mars Reconnaissance Orbiter, and just a couple of sort of interesting stories in the last couple of weeks. One is a paper was released analyzing this area, which is down near the southern polar region of Mars. And it's a very complicated sort of blocks and grooves and whatnot. But there's also a spectrometer on board MRO that allows them to come up with an idea of what the mineralogy of the surface is. And they're seeing lots of calcium and magnesium minerals, and those typically things like serpentine and talc. Those are the types of things you see in hydrothermal areas on the Earth, areas where you have volcanic material subsurface that heats water. The water flows through the surface, or else it's buried like under an ocean, and alters the minerals to that sort of composition. And so this is the area that this is in. Actually, this is where that previous image was taken. And based on the minerals they're seeing, they're hypothesizing that this area was deeply underwater, probably a couple billion years ago. And if you look at just the topography here, this could be a kilometer or more of water sitting in this depression. And so this is sort of a cross-section of how this might have happened, where you have a big depression. You've got water has collected in it, but then you have magma bodies subsurface. Water starts percolating upward, and you get all these minerals being formed by the hydrothermal system, the hot water venting into this sea. And so you get all of these enhanced mineralogies. And this is probably the best evidence that we've had so far of this type of activity on Mars. We certainly see widespread areas of volcanic activity, but to have that in conjunction with standing bodies of water, that's what's exciting about this. And of course, the subtext on this is the type of environment on the Earth that we think where life first originated, that you have this sources of energy. The minerals are very conducive to things like algae and bacteria being able to metabolize some of these sulfur and magnesium minerals. And it's a very similar environment to what we see in the mid-ocean ridges on the Earth, these trenches where you have like black smokers and hot water venting out, and lots of life living in the surrounding areas of these vents. And so that's an area that we will certainly want to investigate a lot more closely when the opportunity arises. Okay, and then this is just it's just visually interesting. This is a sand dune up near, near the south polar region of Mars, and you've got all these sort of grooves running downhill. So this is the top of the dune. This is a fairly steep downhill slope, and you see all these parallel ridges, which we see these in a number of places on Mars. And sorry, I got ahead of myself. So there's a theory that's being put forward that in the winter time in this area, and this is true, we've measured it, you get carbon dioxide ice forming on the surface. It's cold enough that you freeze CO2 out of the atmosphere. And so you make dry ice up covering these dunes. And then in the springtime, when the ground starts warming under sunlight, then that ice starts sublimating or evaporating into the atmosphere. And this may be what happens.
A wooden block, and it moved 3 inches and then it stopped.
So this
The
is
dry ice block, we expected to
Death
see
Valley.
a bit more activity, but we didn't expect it to
That's a
just
block of
move,
dry
and
ice.
which is more like 6 degrees. It's very shallow. We put the block on and we pushed it, and it would just slide right down. And the only reason it stopped is because it hit the bushes at the bottom. Dry ice, as it heats up, turns into gas. It pushes against the sand as it comes out. After a few hours, it's scooped out a nice little area, and so you have a feature that looks like what we see on Mars. They will move down that dune slope and carve out a shallow trough. When the block of ice is on the sand surface, that sand is just a little bit warmer, and so it causes a cushion of air to form, and that lifts that block just a little bit, so when it moves forward, it's like it's lubricated and it can just slide very easily. Then when it got to the bottom, instead of just sitting there, it would disappear as the area heated up, and then that could possibly leave a pit. I'm looking forward to the day when astronauts can engage in a whole new area of extreme sports. They could snowboard down these carbon dioxide covered dunes on a cushion of carbon dioxide. They would just shoot right down those slopes. It would be amazing.
So dry ice snowboarding. We'll have to try that here. Okay, and then this is just one final image, which is really cool. This is in the north polar region on Mars, and in the north you get these very long, skinny sand dunes. And so this is in the very early spring, late winter, early spring, and so you deposited carbon dioxide frost and water ice frost on the surface. You're starting to break through that just with the heating from the sun. And so once you get enough of that sublimated into the atmosphere, then you're down to the underlying sand, which is very dark. And so you get these, it almost looks like an oil spill coming out of the dunes. And so here's a quick discussion about the observations of that.
This image shows a dune field in Chasma Boreale, which is a large trough that cuts into the North Polar ice cap. Some of the dunes in this image are quite long and sinuous, with a slight bulge at one end, like a head, giving it the appearance of a snake. However, most of the dunes visible here are of the type referred to as Barshan, which are characterized by their crescent shape. For these types of dunes, the mouth of the crescent points in the downwind direction, indicating that the winds are traveling east-west. The diverse dune morphologies here suggest that the wind direction changes over a very small area. When we look at this image, Mars was in late spring. At this time of year, the dunes in this image are almost completely covered by frost. But this will soon change. Small portions of the underlying dark basaltic sands of these dunes are becoming increasingly visible with the active removal of their seasonal coating of ice. A look at a series of images demonstrates the transition from early to late spring, marked by defrosting and the gradual growth of dark spots. By summer, the dunes will be defrosted and will appear completely black.